Okay. All right. So launching right along here. Again, as we looked at it yesterday, um, we we have a similar approach to naming things that are covalently bound as we have to those things that are ionically bound. We start at the beginning, work our way left to right, and we want to make sure that we have um, a um, a quick ability to go back and forth between symbol and name, symbol and element name. The nice thing about covalent bonding is it is between just a few kinds of elements. There aren't very many to memorize. You have all of your gens, hydrogen, nitrogen, oxygen. You have all of your enes, which are very often ides. Fluorine, chlorine, bromine, iodine, which we say iodine for whatever reason, and a few other odd ones, carbon, sulfur, phosphorus. Don't really follow any naming pattern. But if you get your gens and your enes, and just remember the other three, then you're in good shape. You're in good shape. Morning, Emirates. All right. Then, of course, you have to say how many there are because in so many instances, there can be different combinations. And that's the fifth section of this chapter, is a really fundamental idea of chemistry, which is to say that you don't have just one option for combining things. You have many options. And that's what helps lead to biological molecules actually working, because carbon in particular, but also sulfur, phosphorus, nitrogen, they have multiple ways of combining with each other, and with oxygen, the most common element. Oxygen is by far the most common element. And so it works into all of these molecules quite frequently. Anyway, the more you study about this, the more you realize just how deep of a subject this can become. So let's stay at the surface, knowing the names of the elements, knowing the symbols, and knowing their basic what would be charges if they were ions. At least knowing how many valence electrons they start with, and knowing that you can have multiple different ways of combining them. All right, let's get on to a new slide now. All right, so CO is carbon monoxide, and CO2 is carbon dioxide. Remember, di for two, not bi, di. And further, it is not monooxide, it's monoxide. But if we had nitrogen, then it would be mononitride or something like that. Cl2O8 has 2 chlorine atoms, 8 oxygen atoms. There's your ene and your gen. So we have dichlorine octoxide. It's not a very common molecule, but there you see an example where the first element does need to be numbered as well. It's not just chlorine octoxide, excuse me, it's dichlorine. It's also one of the few elements where you have multiple, you have oxygen-oxygen bonds. All right, so now, what is going to be the name? And I'm asking you to put this in the chat privately to me. What will be the name for N2O? N2O. And I'll let you know there are multiple combinations of nitrogen and oxygen. So you write in the chat privately to me, please. What will the name of that be? It's not about being right or wrong, but taking a chance. So feel free to be wrong. N2O. What's the name of that? Okay, I have answers from 4 people. Okay, so remember that you can send me a message privately. Okay. All right. 1, 2, 3, 4, 5, 6, 7. We're almost halfway there. Okay. Let me write in the chat what it should be. And I didn't see this as the answer from anyone, so we need a little bit more practice. Anyway, it is dinitrogen monoxide. So the little number 2 after the N tells you that there will be 2 nitrogens, and the prefix for 2 is di. And then we have 1 oxygen, so we need to specify it as monoxide. 1 oxygen. Dinitrogen monoxide. It is not dioxide. I saw some dioxides. There is only 1 oxygen there. Normally in English, when we have a number, we put the number before what it is we're counting. 2 cars, 3 streets, whatever. But in this, system with the symbols, the number is a subscript. It comes right after what we're talking about. So the 2 there goes with nitrogen. So dinitrogen. And a couple of you had dinitrogen, so that's good. But because there are multiple combinations of nitrogen and oxygen, then we do have to specify how many oxygens there are there. We do have to write the mono. And that's the part that nobody included. So let's look at PCl3. PCl3. All right, so again, please send me what the name is going to be in the private chat. And just to make it clear that it's not PCI3, it's PCl3. All right, so again, send me what is the name of that in the private chat. PCl3. Okay. I see some people giving themselves some negative self-talk. So please don't do that. All right. Everything is difficult at the beginning. Please don't worry if you don't understand it yet. Okay. A little more time for anybody? Yeah, the P name is not the easiest one to spell. That's true. Okay, now this is one acceptable answer: phosphorus trichloride. You may also, just to cover your bases, say monophosphorus trichloride, because you don't know. There could be another combination of phosphorus and chlorine that has more than 1 phosphorus. So just to be on the safe side, monophosphorus would be fine as well. As it turns out, whenever you put phosphorus and chlorine together, There is just one phosphorus in ratio, but you wouldn't know that in advance. So now, a couple of people mentioned chlorine in their answers. So make sure that when it is an element, all of column 17 is ene, I-N-E. But when it is in a compound, it's probably going to be ide. So there are some exceptions to that. In just the next section, when we're looking at acids and bases, we're going to have another suffix. So we've been looking at prefixes for numbers. We're going to have suffixes, in particular for the nonmetals. So again, just like in grammar class, in grammar school in 4th, 5th grade, when you studied root words and prefixes and suffixes, same thing here. So hopefully this will be something you've seen before. Or not these exact things, but the process of changing words. Just like in verbs, you want to have the present be ing and the past be ed, and there are some exceptions there. But all right, let's go on to the next slide, which will give us the answers. All right, well, actually the next several slides. So first of all, you need to make sure that it's binary and molecular. Is it 2 nonmetals? You can just say this out loud. You don't have to all write this in the chat.
I believe those are both nonmetals.
Right. They are both nonmetals for A, and they are both nonmetals for B. And a total of 4 nonmetals, but A and B are unrelated. So yes. And while I'm at it, I'll just go ahead and change this to Georgia. There we go. All right. So it's like Times New Roman, but just a little bit nicer. And one of the things that is unique about it is that the numbers actually have lower and uppercase. You're not used to that. We usually write with uppercase numbers. But anyway, it's beside the point. But so first thing first, what do you have? Just looking at the symbols, you've got N, you've got O, and that's it. And the second one, you've got P, you've got Cl. Remember, Cl is, just one thing, it's chlorine. There is no element L. So first thing, you want to make sure it is just 2 nonmetals. Then reuse them in the order that they're written. So you don't say Cl before the P, you don't say the oxygen before the nitrogen. The way that they are written in the formula is how you write the words. Then you need to use the prefixes for the numbers. And finally, you want to change the second element. So the second element in the first one is oxygen, so it becomes oxide. The second one, the second element is chlorine, so it becomes chloride. If we had sulfur, it would be sulfide. Phosphorus would be phosphide. Whatever is second usually has more electronegativity, so it's more towards that top right-hand corner, right? Of the periodic table there. It's more towards that top right-hand corner. Generally speaking, F is the most electronegative. Then you've got oxygen, and then you've got the rest of the halogens. So, and it goes down from there. And about the least electronegative will be carbon and hydrogen. They're still electronegative, but they probably won't have that. There are a few exceptions, but I won't get into those right now. Mostly to deal with carbon and hydrogen, there's a different system of names there. But here we go. So anyway, yes, we've got 2 nonmetals. Yes, we've got 2 nonmetals. Now we've got to have the names, so it's 2 nitrogen, sorry, names are nitrogen and oxygen. You have to know the numbers, 2 and 1. So we want to have the prefix di for 2 and 1 for mono. All right, so it's quite a few transformations at once, and I want to recognize that it's not simply transforming the symbol to the name. You have to do a few things, but that's why the symbols are so powerful, because they communicate so much in just 3 keystrokes. you know. So N2O tells us a lot. Dinitrogen monoxide. PCl3, phosphorus and chlorine, phosphorus trichloride. Now, they're telling us after the fact we don't use mono, and they don't tell you why, but I've already told you why, which is that as it happens, when you put these two elements together, you can have multiple numbers of chlorine, but you end up with just one phosphorus in each case. All right. So, yep, you do that. All right. Going the other direction, if we have tetraphosphorus trisulfide, we have tetra and tri, so they have to be 4 and 3. You just need to know those prefixes. You know those Greek numbers, tetra, tri. And so you have to know, of course, that phosphorus and sulfide, phosphorus is P, sulfide means sulfur, and so that's going to be S. So P4S3, P4S3, and not PS5, but P4S3. So as you are going through there, you got nitrogen trifluoride. It's not mononitrogen, but if it isn't specified, then you can go ahead and presume it is 1. So in your private chat with me, please go ahead and write the formula for nitrogen trifluoride. And I know you can't do subscripts. Just make sure that the number goes after the symbol, goes after the element symbol. All right, go. So just for A, nitrogen trifluoride. I've got answers from a couple people.
Are we answering both at the same time or just
Nope.
A?
Just always one at a time. Yeah, so this time it's A. This time it's A. Nitrogen trifluoride. All right, we're up to 6 now. All right, there was a lot more success here. Again, just as a form of etiquette, you do not need to indicate your uncertainty about an answer you give. I don't need to know whether you are confident or not. You want to just state your answer, and if it's right, it's right. If it's wrong, it's wrong. You're not being graded here. So, in any case, nitrogen trifluoride is going to be NF3. NF3. Now, if we could do subscripts on Zoom chat, then I would want that 3 to be smaller. But there you go. All right. Okay, now, we don't have time, unfortunately, for disulfur dichloride, but remember that di means 2. Di means 2. And so if I have disulfur, then I'm going to want S2, because the symbol is S. And if I have dichloride, I'll have 2 chlorides, which is chlorine. And so I will have Cl2. And again, it is, oops, just sent that to the one who sent me one. Let me try this again. S2, Cl2. And again, you want to make sure that your L is lowercase. The second letter in an element name is always lowercase. The And here we go. That would be the answer right there. Here on slide 28, S2Cl2. All right, you're free to go. Thank you for coming, and I hope that you're able to continue to work on and finish those skill sheets I gave you yesterday, and have a good afternoon.
Have a good day.
Bye-bye.